class. Today we're going to start chapter 10 and we're going to look at this idea of order of real numbers. Now, what are real numbers? Well, if we go back and talk about the definition of real numbers are a combination of all the number systems. So basically, a real number is any number, whether it's rational, irrational, or integers. Now, for just a second to get started, let's go ahead and look at our number line. And we're going to see that a number line shows order relationships among real numbers. So if I have this number line, and we're going to work in algebra, so we're going to have integers. Do you remember the definition of integers? Yes, integers are numbers and they're opposites. So when we review this, we're going to see that integers are not fractions, integers are not decimals, it's just a number and its opposite. So if I have my number line here, who's right smack dab in the center is 0. The numbers to the right of 0 are positive, and the numbers to the left of 0 are negative. And we can use this number line to help us order numbers. Let's say I put a big fat juicy dot here at -3 and +2. Well, we could say that -3 is to the left of 2, which means -3 is less than 2. And we can take that and write it as a sign. -3 is less than 2. Now, if you recall, we have 4 different types of inequality signs. Those inequalities can be less than or less than and equal to. They can be greater than or greater than and equal to. And I don't know if you remember back in elementary school, your teacher may have said the alligator's going to get the birdie, or Pac-Man always eats the bigger number. I like to say the big fat side is by the big fat number. So whatever acronym helps you to learn. So the whole idea here then with ordering on relationships, if I can get you to visualize the number line, that's going to help you. Remember, the more to the left it is, the smaller it is. So that means if I'm dealing with negative numbers, the closer that negative number is to 0, the greater it is. So we're going to take this idea and we're going to let it help us translate statements into symbols. If I take this first equation here, how would I write -5 is less than 3? Well, -5 less than, remember the less, diagonal to the left, less than 3. Okay, if I look at this next one, and if we're going to write the statement that goes with it, it says 6 is in between -8 and 8. Well, if 6 is in between, we're going to put -8 is less than 6 is less than 8. Now, on these inequality statements that have 3 terms in them, as long as they're in numerical order, either going forwards and backwards, it's okay. -8 is the one furthest to the left, 6 is in the middle, and 8 is the number that's all the way to the right on our number line. Okay, now let's look here at the last one. It says the number n is at least 2. Well, it's algebra, so we've got to get some numbers in there. And now, if it says it is at least 2, that's the lowest I'd be, but it could be greater. So when it says at least, we're going to write greater than or equal to 2. Now, just a little sidebar here. The other important one you need to realize is at most. If it's at most, then it's going to be less than or equal to. And I think I'd make a note of that because we're going to see those a little bit more now that we're in the inequality chapter. So let's look at these equations here and classify whether they're true or false. If I look at the first one, absolute value symbols are back. We've got the absolute value of -25, which is 5. Is 25 greater than 10? Yes, the big fat side is by the big fat number, so we would say that is true. Let's look at our second one. If we look at the second equation here, now look, those aren't in numerical order. You got to really pay attention when there's negative numbers. Remember the -4 and the -5 need to change places for it to be true. So this answer that number line, it's going to really help you decide whether these sentences are true and false. Well, let's look up here at our next activity. They're going to give us an inequality, and they're going to give us a set. And we've got to look at this set. It says E, that means belongs to. So we are actually going to go through and try every number in the set to see if we get a true statement. So if I look here and I plug in -4 squared is, that's right, 16, and 16 is greater than 10, so this one works. How about if we plug in a -3? Well, -3 squared is 9, that's false, so we're not going to worry about that. If we plug in a -2, well, that's going to give me 4. 4, it doesn't work. And you're going to go through here and realize when I plug in all these guys, that doesn't work. They're only 4 and -4. So my solution set is going to be -4 and 4, because those are the two values in our set that give me a true solution. All right, so now we need to figure out how to graph these inequalities. Now we're going to graph each inequality over the given domain. Now, if you remember a few minutes ago, we reviewed what integers were. Integers are numbers and their opposites. The other thing we have to worry about is our inequality signs. Hopefully you realize when I look here that I have less than, equal to, less than, equal to. So this is saying they want the positive integers between the numbers of 1 and 6, and we're including 1 and 6. So remember, integers are only the numbers and their opposites. It doesn't include fractions or decimals. So we're going to go through and put dots on those numbers between 1 and 6. It includes 1, 2, 3, 4, 5, 6. And because it said less than or equal to, we include 1 and we include 6. Now, when I go down to the next graph, this time they want the integers, so numbers and their opposites, between -5 and 1. Now, if you notice that I have a less than or equal to in front of the -5, but it only says less than in front of the 1. So that means we want to include -5. It's going to get a dot, -4, -3, -2, -1, and 0. But it said it had to be less than 1, but not less than or equal to, so we don't put a dot there. Now, the only other situation we need to look at then would be number 3 here, and they want me to graph the real numbers between 6 and 0. Now remember, we said real numbers are all the numbers. It includes fractions, it includes decimals. And the other thing you're going to see here is it only says the signs do not have equal to underneath. They don't have the line underneath. So that means we don't include 6 and 0. So when I go to graph these on the board, I'm going to go to 0, and I'm going to put an open dot. Since it didn't have the equal to sign underneath, we're not going to include 0. And we're going to go to the 6, and we're going to put an open dot, and then we color in the line in between. So the idea here is if they want integers, we're just going to have dots on a number line because it's only that number or its opposite. If they want real numbers, that includes everybody, rational, irrational, decimals, fractions, and so we color in the whole line. All right, so that's our lesson for today. Thank you.